So I'm going to go through an example problem using Simulink and MATLAB, covering the materials in Module 5 for our ME111 System Dynamics course. So let's take a look here at example problem 5.5.1. So we're looking for the Simulink solution of our y dot is equal to 10 times the sine of t. So we're going to use Simulink to solve the following problem for time from 0 to 13. So our y dot term here can be written as dy dt, first time derivative of our function y, and this is equal to our 10 times the sine of t, where our initial condition here is that y of 0 is equal to 0. So when time is equal to 0, this whole function goes to 0. So our exact solution here is y of t is equal to 10 times 1 minus the cosine of t. So we're going to start from the very beginning here. How do we solve this problem using Simulink within MATLAB? Well, the first question is, how do we get Simulink opened within MATLAB? So what we first want to do is start a new MATLAB window here, pop open MATLAB, run it. I'm just using the release 2020A from the university here, so you should be able to go through and download that. If you haven't downloaded that yet, I will put up some links for you to go to the UVM site in order to download the MATLAB. We want to make sure that we do have the Simulink add-on within it as well. So once we have established that, we have MATLAB and Simulink downloaded, what we do is in our command window down here, we type in Simulink and hit enter. What that will do is it'll pop open a separate window with Simulink. So here it is. Here's our window that's going to pop open. You'll see your Simulink window pop open, and you'll have all these different options within here. So what we want to do is choose a blank model. So you can see what I have boxed in here. Here's our blank model. So we'll click on that. And when we click on that, it'll pop open this right here. And we can see we have our option up top here that I have boxed in red for the library browser. So we want to double click on our library browser there to open up our Simulink library browser here. Then what we're going to do is we want to select the sine wave block, and that's under the sources category. So if we come over here under Simulink, we can expand this out by clicking on this arrow here. We go down to sources, and when we click on sources over here, we can see all the different options that pop up over here, and the one that we want is sine wave. So we can select our sine wave one. So we take that sine wave block and we click and drag it and put it right here in our workspace there. And what we can do once we have that is if we want to set any of the parameters of our sine wave, we can double click on the sine wave block there, and it'll open up this window here that shows the block parameters for our sine wave. So what we want to do is we want to make sure that we set everything, all of our parameters correctly. So we want our amplitude to be set to 1, our bias to 0, our frequency to 1, our phase to 0, and our sample time to 0, and we can click OK. So we can see down here, okay, this right here, that's where we set our amplitude to 1, right there. We set our bias to 0. There's our bias right there. We set that to 0. We set our frequency to 1. Here's our frequency right there. We set that to 1. We set our phase to 0. There's our phase right there. We can set that to 0. And here is our sample time. We want to set our sample time to 0. We can set that right there. We can type those all in. And once we have everything all set for our parameters, we can click our OK down here. So now that we have that in place, the next thing we want to do is select and place our gain block. And this is under our math category. So we want our gain block under the math category. We go back over here to Simulink. This is expanded. I go down to my math operations. I click on that. I look over here on the right. Oh, look, there's my gain right there. So I can grab that and I literally click and drag it into my workspace just like that there. So the same thing. Once I have this in my workspace, I've clicked and dragged my sine wave and my gain, put it in my workspace over here. What I want to do is I now need to set my values for my gain, so I can double click on that guy there, and I get my block parameters will pop open for gain here. And under main right here, I can set my gain. I type in 10 right there, and then I can click OK. So thing to know about all these blocks that we can do within Simulink is we can change the visualization of them. We can move things around, we can click and drag it wherever we want, but what we can also do is we can change the size of them too. So what I want to do here is I come down to the corner, if I click on this and drag it, it'll expand the size of this here, so it's a little bit easier to read if there's a 10 in there or something else in there. So it's a little bit easier for the text to be visible within our diagram. So the next thing we want to add in is our integrator block, and this is from our continuous category here. So we go back over to our drop-down menu under Simulink, go to continuous right there. I click on that and I see over here, there's my integrator right there. I can click that, drag it back into my window over here. And now we can see, okay, I've dragged it in. There it is right there. I can double click on this, and when I double click on it, I can get the block parameters window to pop open. So there's my block parameters window right there. And we can set the initial condition to 0. So there's our initial condition right here. We can set this equal to 0 right there, and then click OK. The reason we set this to 0 is because our initial condition here of y of 0 is equal to 0. So we're inputting our initial conditions right here. So again, I mentioned this a little bit in our overview. This really does help us give a visualization to these problems. We can see it in the block diagram. We double click on each block and we can see, oh, that's where I set my initial conditions. This makes sense on why I'm using these equations. So now we need to actually see our results. In order to see the results, what I've done is I've decided to add a scope block from our sinks category right there. So we go back to Simulink, our expanded option. We come down to sinks right here. Come over, click on that. We can see there's our scope right there. Then we can grab that, click, drag it into our window over there. So once you've placed the blocks where you want them, you've resized them so everything looks the way you need it to look. You can see all the values inside correctly. Then the next step is to connect the input port on each block to the output port on the preceding block. So in order to do this, what you do is you click on the preceding block, hold the control key, and then click on the destination block. Simulink will then connect the blocks with an arrow. So you come down, click on it, hit control, go to the next one. So this right here is where you're going to click right there when you hold down the control key, and it'll connect it over to the other block. So once we've done all this, we get something that looks like this here for our diagram. Key parts we're going to be using for this particular problem here, we can see there's our library browser button right there to get to all these blocks that we were bringing in. Here's our runtime that we can input right into this window here. Here is to actually start and run the simulation right there. And then we can see what our default solver is down here in the bottom right. So the next thing that we want to do is we look back at our problem statement. It told us 13 was what we wanted to do. It comes defaulted to 10. So we want to delete that and replace it with a 13 right there in our stop time. And from there, we're ready to go and we can hit run. So again, there's our run. So the start simulation icon right there on the toolbar. So now after you clicked run, you're going to end up hearing a bell sound when the simulation is finished. So then you should see an oscillating curve, an amplitude that was given to it that we put in as 10 and a period of 2 pi. And if you don't see this scope right down here pop up right away, double click on the scope icon right there, the little block, and this will pop this up. And you can see, okay, there's our amplitude from 10 to 20. So there's our amplitude right there of 10. And we can see our period right there of 2 pi. So everything checks out to how it should. Independent variables of scope on the block is time, and the input of the block and the dependent variable is our y, and this is going to complete our simulation. Now, the thing to note is that the default solver is our ODE45, a variable step solver that is automatically selected by Simulink. By clicking on this item down here, you can specify which solver you want to use.